Two students, here's a video for section 5.2, example 1. They have a bunch of rules here that we're going to use. Probably be most useful when we use them, but let's see if I don't like their examples as much as I like mine. Product of powers. So if you have x to the third times x to the fifth, that equals x to the eighth. You end up adding the exponents when you're multiplying. If we're dividing, like if we had x to the fifth divided by x to the third, we would subtract. 5 minus 3 is 2, so this equals x squared. If we have a power to a power, this is where we actually multiply. We don't multiply when we're multiplying. When we're multiplying, we add the exponents. When it's a power to a power, we would multiply. So x to the third, and then that whole, x to the third, that whole quantity raised to the fifth would be x to the 3 times 5, or x to the 15th. Okay? And it will make more sense when we do some examples. AB to the m, if we had two different things here raised to the same power, you can break it into two parts. Okay? I don't think I need to redo that one. That one makes sense. You can put the m to the a, and m has to be applied to the b. And if we ever have a negative exponent, we can rewrite it as a positive exponent, but we just have to write 1 over. All right? Let's see if we can apply all of those properties to the problems that they give us. All right, we have the same base, 81. So if we have the same base and you're multiplying, we need to add the exponents. So 5 6 plus negative 1/3. Negative 1, I need to have the same denominator to add, so negative 1/3 would be negative 2 6. So 5 6 minus 2 6. So I'm adding. It is kind of weird. I'm adding, but it's because it's a negative, it's like I'm subtracting. It's 3 6, which is a half, so 81 to the 1/2. The 1/2 means the square root, so the square root of 81 is 9. If I just wrote 9, that wouldn't be really showing that I used the properties of exponents, so that's why I wrote it like this first. Otherwise, you could just type that in. All right, what's next? How can you rewrite these using the property of exponents? So I'm going to start inside, and I like to simplify what's inside the square root. All right, I try to simplify. It's like PEMDAS, right? Parentheses first. So inside the parentheses, I notice I have an x on the top and x on the bottom. So that's like x to the first power. Since I have the same base, x and x, and it's a division problem, when we divide, we need to subtract. So 1 minus a half is a half. So I'm going to rewrite what's in the parentheses as x to the half times y to the third. And that's my first step. My first step is I simplified what was inside the parentheses. I can't do anything with the y's because it's just y cubed. There's no y's down bottom. And 1 minus a half was a half. All right, now that I have this, and I have this power outside, I got to apply this power to that power. It's a power to a power, if you recall from earlier. That means we multiply. So let's see, I have to multiply 1/2 times 2/3. A half times 2/3 is 2 6, which reduces to 1/3. So I have, for a final value of x, x to the 1/3. And for the y values, I have y to the third times 2/3, and 3 times 2/3 is 6/3, or 2. So how can you rewrite it using property of exponents? what the original problem can be rewritten as what I just wrote in blue. I did the subtraction rule, and I did the power to the power rule. Let's see what else they have. Oh, they're ready for you to try some. Wow, 32 to the 2/5. See, I don't think they give us that many examples, so I'm going to just jump right to it. If you want to, click pause and come back. I'm going to jump right to it. 32, I know 32, if you know your bases, 32 is 2 to the 5th power. Because it's 2, 2 times 2 is 4, 2 times 4 is 8, 8 times 2 is 16, 16 times 2 is 32. So I'm going to use that. 32 is 2 to the 5th power. I like to write everything that I can in terms of 2, 3, or 5, the basic prime numbers. Whoops. So this is really 3 over 2 to the 5th. But the 2 to the 5th has to be raised to the 2/5. This is a terrible way to write it. And then I have the whole thing to the 1/2. The reason why I changed 32 to the 2/5 is because now I can multiply these powers. 5 times 2/5 is 2. So I'm just kind of going piece by piece. I changed the 32 to the 2 to the 5th. Then I can multiply these powers. 5 times 2/5 is 2. So on the bottom I have 2 to the 2nd power, which is 4, but I'm not going to write that yet. And then the whole thing is to the 1/2 power. Alright, I guess you could have typed in the calculator 32 to the 2/5 and got 4, but that's not really showing you're using the property of exponents. You could type that whole thing into a calculator to get the final answer. So to show property of exponents, I changed the 32 to a 2 to the 5th. Alright, I got 3/4 to the 1/2. Well, 1/2 means square root. So can I take the square root of 3? Nope. Can I take the square root of 4? Yep, the square root of 4 is 2. So my final answer is 3 to the 1/2 over 2. Or I guess I could write it, I shouldn't write it with exponent. I shouldn't write it with exponents, I should write it as square root. Square root of 3 all over 2. Here's the final answer. What's the next example? Alright, if you want to, try this one, then come back when you're ready. Alright, in the parentheses I have a, b to the 1/2. I don't have any division, I don't have any other a's or b's, so I think I'm stuck right there. But now I can apply the 2/3 to it, so I go a to the 2/3. I'm going to rewrite the whole thing. 2a to the 1/3. And now to this parentheses, I'm going to apply the 2/3 to both parts. So I'm going to have a to the 2/3. And for the b value, I have 1/2 to the 2/3, so that means I got to multiply 1/2 times 2/3 is 1/3. And now I don't have any exponents anymore, so I have 2 times a to the 1/3 times a to the 2/3 times b to the 1/3. So I'm just looking for the same basis, and I do. I have the same base right here. I have a and an a, so I can add these because it's multiplying. Everything's being multiplied. That means I can add the exponents. Final answer, 2a 1/3 plus 2/3 is 3/3, which is just 1, but I don't have to write it. And then b to the 1/3. Now maybe the answer key doesn't have fractional exponents, so I could write that as a cube root. So maybe, I don't know what the way the answer book writes it, but maybe you would have to write it like this with the cube root. That's what 1/3 power means, cube root of b. Alright, that's it for example 1 of section 5.2. Have a nice day.